Welcome, coming at you live from my office in San Jose, California. It's time for more test-driven development in Swift, where we are nearing the end, I believe, of a journey. Hey, Mudshark, welcome back. Mudshark in Sweden. Glad to have you. And this will likely be the last stream I do this year, as I've got family coming, invading our home in a few hours, and I'll want to maximize all my time with them. So, Merry Christmas, Happy Hanukkah. Wish you a blessed festival of lights if you're in the northern hemisphere. If you're in the southern hemisphere, then I don't know, it's not winter, so what kind of celebrations do you do in December? I don't know, but we are coming up on a new year. Hopefully more hope coming at us this new year. Hello, Javier in Louisiana. Welcome. Glad to have you. Let's see here. Let me switch over to that screen and just mention that, oh, look at my face there, coming at you twice. I am now on the list of instructors, having taught my very first testing and refactoring workshop at Industrial Logic for a client. This was a group of, I want to say about 25 iOS developers at a large financial institution. I took them in 2 groups because it's kind of hard to take that many people online in an online workshop. But this was my best training, I think, ever, because of all the stuff I've learned from Industrial Logic that I can now pass on to you, and you're already getting some of the benefits on this stream. Last time, I got some comments, including from Mudshark. Let's see what we got here. Hi, John. I was thinking about the sorting that's coming up. Should the sorted problems, desires, and killer features always be separated? Or should it be possible to display them all in a single list? So I wonder, should the scored entries be stored in 3 arrays or in 1 array where you can filter the results to get what you want? That's an interesting question. And offhand, my gut response is that we probably want them in 3 because they will receive different scores. As for example, if a whole lot of people are like, we want Swift UI, well, that'll rank up even if they completely disagree about other things. So the other thing is that for the purposes of what I'm trying to do, which for those of you who don't know, I have a survey and I'm writing a program to score the survey results about what people would like in terms of more teaching from me. Me being the one and only client, what I want is scores. And I want to get there in the easiest way possible, not necessarily the most efficient way. So, Mudshark, what you're suggesting may be valuable, but probably not immediately. That is, it might be a refinement down the road. With test-driven development, and with story slicing in general, what you want to do is get value early. And then as you discover more about the domain, say, well, maybe this belongs over here, maybe that belongs over there. So I'm not going to follow this path. But thank you for the question. I hope that makes sense. You can always, I mean, you're here, you can always ask me. Had some more questions here from a Stephen Williams. Could you go into more detail about deleting tests? I am nervous when deleting tests that I might accidentally leave a hole in the test coverage. Is it just the Z's and the O's, that is the 0 and the 1 cases, that you delete? Are there any guidelines or procedures for this? So when you build up things taking the 0 case and then the 1 case, and then you get to the many case when you're dealing with, composite data of some kind, then as soon as you can get to the many case, then the 0 and the 1 tests are no longer adding value. They were scaffolding. And we can then remove that scaffolding as they have served their purpose of helping us move in small steps. But it is, if the 0 case fails, it's I can't. There might be a time when you might leave the 0 case in, but it'd be unusual. As long as it's handling like a collection, the many case, then I'm happy getting rid of the 0s and 1s. Other cases where I am not shy about deleting tests are, well, the 0 and the 1 is like a specific instance of that. In fact, let me see if I can go to the code. Right here we have multiple entries with duplicates that and that should become a distinct list of problems. I think that was the last place we were. Let me check my history here. Here's the remove scaffolding. Yeah, answer accumulator. Here we go. So here's the 0 case and the 1 entry case, and then I built up to multiple entries, and then I'm like, yeah, multiple entries with duplicates. These were building on each other. There are other times when I use scaffolding. I understand the fear, the worry that, whoops, I don't want InDesign. Go away. Go away. I meant Safari. Other times are anything that follows this pattern where I'm building up to a more complex test, where the complex test envelops the simpler test. That said, if you feel nervous in any way, I would say there's no harm in leaving the tests there. Not much harm, except for noise and maintenance. So there is a price. All code has a price to it. But if you feel nervous, keep the tests there. In fact, sometimes having TDD'd something, I will still have this sense of nervousness about, but does it cover this case? And so I'll write a test to find out. And if it does cover that case, I may keep that test there just because I had that weird feeling, and I want to leave it as documentation that, look, it's okay, it's cool. The test is covered. That particular case is covered by this test. Here's another thing from Stephen Williams. You can use a more succinct set initializer in the assert than the array literal one like you did in the implementation code. Let's try that. I actually took a peek at it beforehand, so I already know where this is going, and I like it. So not here, but in the test code here, where I'm calling set with an array literal of comma-separated values, which can go on and on. What he is suggesting is that this will automatically get converted up. So specifying an array here, but having a set on this side, Swift will, it seems very lucky for us, it'll automatically promote this. It'll try to resolve the types by trying to promote one, and it can promote an array into a set. This is a set of strings. And oh, I shouldn't start without writing tests. Oh, I didn't mean to leave that those coaching suggestions on. Oh well, I'll leave them on. Let me start with just a green build, just so we know. Always start from green, end in green when you're refactoring. And here, if we go like this and change this to an array, and that reads much nicer. Look at that. We reduced gobbledygook noise, and it's still green, so I like that. So this is a test-only change. Use how about that? Simplify set equality assertion as a micro commit. All right. So I think that's it on the comments from last time. What do we want to do? Where are we going in the next 45 minutes or so? Let's look at what we have. What I want is we score problems, we score desires, we score killer features, and we assured that the problems are distinct. That is, by using a set, the ultimate output is simplified. Let me, I'm not quite sure where we're going yet. Bear with me. This is live coding. Yeah, so we can score problems, score desires, score killer features. These are the three categories of things that people answered in their surveys. And that's by looking for a particular string. What we don't have is a way to say, okay, oh, I think that must be part of what this was. Yes, that's where we were going here. In order to say, well, I want all the scores, then I need to iterate over each of the things, but uniquely. That's what this was for. Okay, just getting back. I should have left a to-do. Maybe if we don't finish this time, I will leave a failure of some kind to indicate where to continue. That was my bad. If you have any questions as we continue, do feel free to pop them up in the chat. They may be related to what I'm showing. They may be unrelated to what I'm showing. I'm happy to have have dialogue with you on any topic. So we can get problems distinct, and where did the... I'm trying to see. Okay, so accumulate created a set by taking the union. It did this to get the set of problems. We really need the same for each one, but maybe before I do that, it would be best, instead of going wide, it would be best to go deeper and say, well, let's use this first before I repeat it for desires and killer features. I'm just going to read this username. I believe it says, I am a llama. 17. Hello, sir. I have a question, but it's irrelevant. I hope I'm not intruding. Well, I'm just getting started, so it's perfect. Developing myself into a natural language processing and artificial intelligence. A few days ago, my computer became unavailable. I want to buy myself a new computer. Do you think the new M1 MacBook Air 16 gig memory is worth taking? I mean, or what do I think of this computer? So I'm actually on a really old computer. I purposely went on eBay to buy a computer that is no longer for sale from Apple. And that is the 2015 MacBook Pro, because at the time, that was what I wanted. I didn't want the whatever that bar thing was at the top. I didn't want the keyboard problems. I wanted a real keyboard. So I bought a 2015. Now that the new machines are out, well, I'm those new machines, of course. But if you are in the market, I am a llama for a new computer. My gosh, the new M1s. I mean, I'm not one. Who else out there has an M1? Everything I hear about them is, wow, in terms of processing power and low battery use. The one issue is if everything you need is supported. Like there were folks having trouble with Docker, but I think those issues have all been resolved. Fanless, yeah. I think the M1s have been out long enough now that most of the issues have been resolved around compatibility of tools. So I think you won't go wrong by getting an M1. And without a fan, that would be pretty sweet. Good luck to you. All right, so rather than getting, rather than getting the problems and the desires and like repeating this right away, I kind of want to see if things are set up correctly before I repeat them. Basically, I want to iterate over all of these to get the scores. So let's do that. You're welcome, I am a llama. All right, so we've proven that we can gather them. And what I want now is to iterate over them to get scores. Let's figure this out. This is like score all problems, and I don't know yet what that means. And for the assertion, I don't know what that means either, but let's start with a comment. Comment is not a bad place to start. Basically, I want to have get scores for P1, P2, P3, where the scores we can figure them out easily enough with a single call, right? That's really what I want. And so now starting with assert first as a TDD pattern. I don't know what the result type is, but what do I expect? I expect a dictionary? P1 is going to be 8. That's not a dictionary. Help me. I need a dictionary of entries. Like, whoop. Do I even have this syntax right? It looks funky. Tuples. Maybe. This is going to take some experimenting. And this is one of the hardest parts about test-driven development, and a good reason to start from the assert first and work backwards is otherwise you're testing all this stuff and it's like, yeah, but how do I actually test? So I'm just going to put it out and we'll refine it as we go. P2 is going to be 8 plus 5, and P3 is going to be 5. I'm just using the same inputs up here. In fact, I can go like this and copy this setup here, this arrange section, something in here. If you remove the parentheses, it would infer a dictionary. What I'm debating about is I want the list, and I also want it. Ultimately, I want to sort the list, but I don't want to sort it yet, right? This is I want to sort a list as the final outcome, but to get there, I just want a list. And it is a good question, Mudshark, of what type is easiest to sort, and I don't know. Is it an array of tuples? Is it a dictionary like this? I don't know. I have to decide. And dictionaries are hard to compare for assertion with assert equal. Like, you probably don't want to do that. That doesn't mean I don't want such an assertion. It just means it'll be trickier to write because I'm not using Hamcrest. Maybe I should use Hamcrest. Decisions. Boy, this is the hardest thing I've faced in this problem so far. How to represent this? I think for the sake of let's do anything just to make progress, I think tuples probably makes sense. It'll do for now. I may change my mind later, but that's okay. So here I want to get a result, which is going to be an array of string to integers. Right, and this should... Why is this complaining? Type string to int cannot conform to equatable. I thought tuples had become equatable. Am I wrong? I know I've blogged about this. Let me do a search. I thought that tuple testing had become, or tuple equality was given for us, but let's just bring in a helper here and then we'll see. Oh, that's it. Ed! Holy crap! You're exactly right, and good to see you, Ed. That was the thing. You can use equal, but not equatable. Well, let's leave this out here. Hello, sir. I wish we could actually talk, but this isn't bad. This is not ideal. Let's see. What's it say? I don't know if it hasn't caught up to me. If this is a ghost error, let's find out. It looks like it's still iffy there. So let me bring over my little helper. My little friend. Oops. Will this... Oh, this is for pairs. Yeah, I'm getting all tangled up. Fine. Let's make a type. This is gross. And I'm going to do TDD like I mean it by defining a type out here. This is really getting gross. But let's call it scored answer, which is going to be equatable. And this is going to be a answer and a score. This is the most tangled I've gotten in a long time. Mr. Bill. I don't think I've called you Mr. Bill before. Mr. Wake. Good to see you too. Welcome. So, Look at that. We got a small party here. So you think dictionary actually supports... All right. If I say, let's turn this into, let's try again. If this is now a dictionary, square brackets. Whew. How long has it been since I've just done a dictionary from scratch? Go with the simplest thing, folks. And this is also why, I've said this before, I'll say it again. This is why ensemble programming is so important. Here we have an awkward ensemble in that I'm getting your input through the chat window and I am driving and navigating both. It would work much better, and I have seen it work much better, where you're actually coding on something for work and you've got more than one head, more than two even heads working on the same problem. So this compiles and looks like something worth pursuing, although I'm still surprised that dictionaries can be compared like this. So thank you, William, for Bill, for pointing that out. I'll get rid of all this gobbledygook. Get rid of this gobbledygook. And now I just need to get this result from something. And what do I want? We're going to accumulate an entry, and then I want to say, score. I've got score problem for a particular problems, or score all, get all problem scores. Something like that. And it's easiest, even though this could be a computed property. I don't know about the complexity. As soon as a computed property is beyond order 1, I get a little concerned. But even if it's not, it's easiest to start with a method call and then convert it later if you need to, because you can do this. Right? This will choke with a fatal error. We can just return that, and this should fail if it well, I'm curious what the assertion is going to say. It's going to say an empty dictionary is not equal to something that resembles this. So let's find out. There we go. Empty dictionary is not equal to P2 of 13. That's 8 plus 5, P3 of 5, P1 of 8. I'm happy with this. Let's get to green. Now we're green with this very literal thing. Score all problems. Score all problems is a better name for this. But first, no, I'll do it here. We did a refactoring, and I am comparing that. This red is, it's an unfortunate leftover here. I'm not quite sure why AppCode hasn't figured out that it's all okay. All right, was a long start because it was hard to try to figure out what type to use and really trying to get to, do anything just to get just to get an answer, because we can fix it up later. But go with simple. Stick with simple. Let me clean this up and let's commit this. This is begin score all problems. Now, this is with one set. Oh, here's something refactoring. The type here, which was helpful to do TDD, is now no longer needed. I can remove that. It becomes, as you can see, a hinted type. It's not actually there. This is a test supported refactoring, so it's R. Actually, it's a test change. All right. Now, this is obviously not what we want. It works for one and only one input. It is wrong for other inputs. And that is telling us that we need another test. But this process of starting with the name of the test first, and I even updated that as I went, and then saying, okay, how do I assert this? Spending all of our time there trying to figure out how do I express this was valuable. And we end up then with a dorky, hard-coded implementation where the value is nonsensical, but we've created all of this framing, this structure around, like, what is this? What does it return? What's it called? Is the test able to talk to the production code? We work out all these problems. This is very unusual to slap in something so complicated, but let's keep going. I'm just going to say score all problems Mark II. P1, P2. I don't know. Bill, is this a case of, if you're still around, where my initial implementation, because this is such a complex problem, is that the dumb solution is not helping us? I'm not sure. But let's keep going with Mark II. Let me change some numbers here and some inputs. I'm going to keep P1, P2, and P3 like this, but let's change some values here. Say this is 10 and 7, just for yucks. So this is going to be P1 is 10, 10 plus 7, and this will be 7. I expect this to fail. Calling the shot, it will have these numbers, 13 for P2 on the left, and on the right, it will say you really ought to equal this, including 17. There we have it. So there's our new failing test. All right. Now, how to do this? I really want to iterate over our problems. And for each one of these, I want to call score, in this case, score problem. And what do I do with that score? I assign it, I accumulate it. So it looks like I ought to start with a result. Can't believe I couldn't remember the syntax for the square bracket syntax for dictionaries. And I want to add this, accumulate this. And there's probably a nice functional way to do this, but I'm going longhand, where I say the result of the string the problem I'm just going to write what comes to mind, even though it may be incorrect. Because this is optional, and so the initial score will be 0. And will this work? I don't know. But I think it might. I predict that all tests will pass. It does. Yay! Let me put this in first. This is score all problems working. Now, you're saying I don't need to add them. I think I do, because this is, I'll show you what I mean. If I take this out, I predict this will fail on 2 tests. Here's the adding that's taking place, where I have one answer where P2 is here and P2 is also present here, and I want to sum their scores. So I believe this will fail 2 tests. It doesn't? Thank you. I am such a dork. Score problem is doing it for me. Dang! Awesome. Right. Score problem is already doing the summing. This is just associating that with the original problem string. Man, I'm a dork. This is why teamwork. Teamwork for the win. This is a test-supported refactoring. That's good. Excellent. This is getting somewhere. All right. Well then, here's the next challenge. How do we make this into a nice, like, how can I avoid the for loop? Is there a way to do that? Loops usually are an indication that there's a functional answer waiting to be summoned. And what I want is just to associate this with that. Not sure. If you can think of it, let me know. If you're watching on YouTube and somebody hasn't already suggested a solution, let me know in YouTube comments. But otherwise, I'm happy to move forward. It looks like this is working. We have 2 versions of score all problems. Yeah, I have a hunch that there's a reduce that will do it. You know, where do we want to try? Let's see. If I say problems reduce result string, the initial result, the next partial result. It's a little different though, because reduce, reduce is doing the summing, and we don't actually need that. I just want to build a dictionary. Yes, a map. A map, I think, would... Sum is adding a value to the dictionary. That's happening here in score problem, which is doing which, as you can see, is doing its own filter and reduce, starting from a score of 0. Maybe a map. Where I say I want to map over I want to map over the problems. The problem is, but it all gets to go into a dictionary in this case. Maybe dictionary is not quite right. Essentially, I want, result. I want a dictionary built up of these. Well, not result. The string to the score. So this becomes a single entry, and I want to accumulate all of these. I don't think this will work. Yeah, it doesn't like that. Uh, zero dot. No, it's not zero dot value. Scores. Yeah, reduce the result. I'll go with your suggestion, Bill. Let's try it. It may be overkill, but if we reduce that with oh, what am I doing wrong? Thank you, Amalama. Come again. You know, I'm not sure. I'm this is where I am a little lost. We have an idea. I'm probably not expressing quite what you're thinking, Bill. That is exactly what I plan to do. Leave it for later. I'm going to put this up there. This has been a good time, a good session. I'm happy with the results, and folks can comment on them. But for now, we've got problem scoring. And honestly, repeating this for the rest of the set, you know, we're so close. We're so close to the end. Maybe I'll just keep going for a little bit. This may run over my usual 1 hour by just a bit. Let me continue this now and say multiple entries which should gather a distinct list of distinct desires. I'm glad you're having fun. This fails to compile because there's no such property. I'm gonna duplicate this and call it desires. And this should fail with empty is not equal to that list there. So that's failing. Passing is easy. I repeat this. Again, this might be why you were suggesting, you know, do I really need them distinct and all that? But this should pass. Good. But I just want to see it work. At this point, I'm so close I can taste it. So this is distinct set of desires. Good enough. Again, this will go quickly. Killer features, where this is going to be K1 and K2. We've got some duplicate code. I don't know. It's not so bad. Test code doesn't have to be perfectly dry. Just has to be easy to read. All right, this will fail to compile because there's no such thing. That's easy. If we get this, this will now fail with empty is not equal to these things. We'll get it to pass by accumulating these. So there's, you know, there's a bit of duplication in here. It's not a big deal. It's not so horribly stinky. If it went on for like more than 3, I don't know, that might be become something to unify. But at this point, this is looking good. And I want to say we now have a distinct list of killer features. And now I'm going to jump to the finish. We've got these, score all problems. Mark II, that's a terrible name. Let's fix that up. But I essentially want this, but for the killer features. Where did I have those? Right here. Not the killer features. I want the desires. Score all desires. Here are the desires. Let's copy those. This will be score all desires, and actually let me bring back the explicit type because it will help. And this result will now be equal to not 10 but 8, 5, and 5. Right? This fails to build. And this should fail. Just clipping along now. And instead of doing the what we did before, to copy and paste this in naively, you know, I have a solution here. And this is starting to look like some duplication here. It really is. But I just want to see it work. Where this is right. This will pass. And it does. So Mudshark, you're asking about triangulation. That's sort of what we did before, where when you start with, you know, by adding more and more tests of the same method, by more tests is more requirements, and the calculations then grow, they evolve over time. That's not quite what I'm doing here. I'm just saying, you know, just do this, do this, do this, and I'm just going to put up with the duplication. We are so close. This is, whoops, this should be score all problems with different inputs. That's not what I meant at all. How is that not? Oh, the suggestion for naming. Yeah, that's not a bad thing. Although the problem is that triangulation is very it's a very TDD specific thing, and I'd rather express tests in terms of the domain. Did I get rid of your score all problems, score all desires? Oh, I must have. Did I delete? I got some naming problems here. This is that. I got things named wrong. This is score all problems with different inputs. This is score all desires. And finally, let's score all killer features. And I'll borrow these. And I'll say these are the Ks, and this fails to build unless I say so. This will fail. And now let me drop this in here, change some names. And this should pass. Great. All right. I think that's good for today. What I want to do next time, and let me put in a note. Actually, let me first, what was the shortcut here? I forget. Commit message history. That's what let's see if I can say. There we go. M. Okay. Where I want to continue, we will have one more session because there are two things I want to do. One is this is definitely getting smelly. Look at all this duplication. There's got to be something better to do here. And the last thing is all of this is taking place inside of this core, which is different from the main, which is a command line thing. I need to basically call this up and pass in some correct calls to get the proper input, or proper output. So let me put in a note here and just say, right? And that gets my attention. It fails to build, and that's a good place to stop. So I hope this was interesting. It was useful for me. Thank you for all your help, everyone who came by and offered, got me straightened out with dictionary syntax. The fact that you can use equality with dictionaries, a surprise. At least it is to me. I don't think that was a part of Swift before, and now it is. So thank you, everyone. I really appreciate all the input. And if you are watching this on YouTube, give it a like and hit the bell. I'll see you around. Take care.